Hi folks, welcome to our very last in our series of lectures on whole numbers and their functions. Today we're going to look at multiplication, division, and then order of operations, what you might more commonly know as PEMDAS. Please excuse my dear Aunt Sally. Let's start with multiplication. So some basics, some vocabulary to know before we get started. The factors are the numbers that you are multiplying together. If I were to ask you, for example, what is 4 times 3? The factors are 4 times 3. Now the answer to what is 4 times 3 is 12, and we call the answer to a multiplication problem the product. So the product of 4 times 3 is 12. You should line up your numbers by their place value for multiplication. Remember, we talked about this with addition and subtraction. That was especially important there. It's not quite as important in multiplication because if you don't line up your numbers by their place value, you will still get the right answer, but you will also probably hate yourself at the end of your problem because it will make it 10 times more complicated for you. So line up your place value, or line up your numbers based on their place value. The longer number should always go on the top row. The longer factor should go on the top. This will result in fewer rows that you have to multiply and, by extension, fewer chances for a mistake, and we'll take a look at what this means in a little bit. So here's our problem right here. We've got 476 times 34, 476 and 34. These are our two factors. The answer to that will be our product. And you can see here I've got the longer number, 476, has got 3 digits, so he's on top. As opposed to this example over here where we have 34 on top and 476 on the bottom. You will get the same answer multiplying both of these, but one of them will require more work, one of them will require less. So why does it matter? Why do you want to put your longer number on the top in your multiplication problem? Let's look at our 476 times 34. So for good long multiplication, you always want to start in the ones column. So we're going to start with our 4, and we're going to multiply him straight across, 4 times 6, and then times 7, and then times 4, going from right to left. So we'll start with 4 times 6. 4 times 6 is 24. We'll write down the 4 in that 24. The 2 in the tens column in 24 will go above the next number over. In this case, that's the 7. So now we'll do 4 times 7, which is 28. 28 plus 2 is 30. We're going to add that 2 to our 28. So we get 30. We'll write down the 0 in the 30, in the ones place. The 3 in the 30, that's in the tens place, will move over on top of the 4. So 4 times 4 now will give us 16. 16 plus 3 is 19. And we'll write that whole number down because there's nothing over here to carry that 1 over 2. So right away, a few things to point out here. You can see that I wrote down the numbers that I was carrying over, that 3 and that 2. I mentioned this in multiplication, or in subtraction and addition, excuse me. Make sure that you're always writing down any numbers that you're carrying, any numbers that you're borrowing. Don't try to do this in your head. You'll only make it harder on yourself. Okay, so we have multiplied our 4 in 34 times 476. Now we need to multiply the 3. And let's go way back to the very first lecture. What place value is this guy in, this 3? You should be very, very familiar with place value by now. If you are not, take some time today and probably tomorrow to go over it. That 3 is in the tens column. And when we start multiplying, the very first number that we multiply, we want to line up in that tens column with that 3. So because of that, when we start a new row over, we add a 0. And now we can start multiplying our 476 times 3. So we'll start with 3 times 6. 3 times 6 is 18, so we'll write down the 8. Our first number lines up with the tens column with our 3. We'll carry the 1 on top of the 7. And then 3 times 7. 3 times 7 is 21. 21 plus 1 is 22. We'll write down 1, 2, the 2 in our ones column. We'll carry the 2 in our tens column. And then 3 times 4. 3 times 4 is 12. 12 plus 2 is 14. So we'll write out our whole 14. So now that we finished our multiplication, we have one more step. We have to add this answer together. So 4 plus 0 is 4, 8 plus 0 is 8, 9 plus 2 will give us 11, 4, 5, 6, and 1. So our final answer is 16,184. As always, grab your calculator, plug it in there, make sure that all of your answers are correct. A note about multiplication before we get any further. I cannot tell you enough how much it will help you to know your multiplication tables for not just this section of math, but all of it, really. The more familiar you are with your times table, the better off you're going to be. So try and get in the habit of spending even just 10 minutes a day going over flashcards, or there are lots of good apps that you can download that will help you with your times table. That is probably the number one thing you can do to help yourself with math. And it's very, very simple. So with that said, let's take a look now at what we would do if we flipped our numbers upside down. Now we have the 34 on top, the 476 on the bottom. Well, our technique isn't really going to change all that much. We're going to start now multiplying our 6 by first the 4 and then the 3. So 6 times 4, like we saw earlier, is 24. We'll write down the 4 and carry the 2 on top of the 3. And then we have 6 times 3. 6 times 3 is 18. 18 plus 2 is 20. We'll write down our 20. Now we have our second row with our 7. So let's do 7 times 4. And before we do that, we need to put down a 0 to make sure that whatever that number is lines up with our tens column, with our 7. 7 times 4 is 28. Write down the 8 right under that 7. Carry the 2 over to the 3. 7 times 3 is 21. 21 plus 2 is 23. Okay, we finished multiplying by the 6. We finished multiplying by the 7. Now let's multiply by the 4. And when we multiply by this 4 all the way over here, we're going to put down 2 zeros to make sure that the first number we multiply lines up roughly in our hundreds column underneath our 4. So 4 times 4 equals 16. I'll write down our 6 and carry our 1. 4 times 3 is 12. 12 plus 1 is 13. And now we'll add. 4 plus 2 zeros will give us 4. 8 and 2 zeros is 8. Here we have 6, 7, 8, 9, 10, 11. Carry our 1. And then 1 plus 2 is 3. 3 plus 3 is 6. And 1. So we got the same answer either way. We got 16,184. But, and I see this a lot with some of my students throwing them off significantly, over here you had 3 columns as opposed to the 2 over here. And those 3 columns just mean you have extra potential for mistakes. So much better to make sure that you're doing your longer number on top, so you only have 2 rows that you're multiplying, 2 rows that you're adding, less potential for missing something somewhere in there. Let's look at a few more examples. Here we have 425 times 84. We start on the right, start with our 4 and multiply it straight across. So 4 times 5, which will give us 20, write down the 0, carry the 2. 4 times 2 is 8. 8 plus 2 is 10. So we'll write down the 0 for that and carry the 1. And then 4 times 4 is 16. 16 plus 1 is 17. So we write down our 17. Okay, next column, now the 8. 8 times 5 is 40. Oh, sorry, before we start with our 8 times 5, make sure we put down our 0. Now 8 times 5, which is 40, write your 0, carry your 4 on top of the 2. 8 times 2 is 16. 16 plus 4 is 20. We'll write down our 0 and carry the 2 for that 20. And then we have 8 times 4, which is 32. 32 plus 2 is 34. And now we add. So 2 zeros here, a 7, 5, and 3. So we should get 425 times 84 will give us 35,700. Again, always make sure that you're plugging your answers into your calculator to double check and make sure that your answer is Correct. Double check everything. How about this? 3,426 times 53. Go ahead, pause the video, try on your own, and then start it up, and we'll double check and see if we got it right. So 3 times 6, our first column. 3 times 6 is 18. Write down the 8 and carry the 1. 3 times 2 is 6. 6 plus 1 is 7. Then 3 times 4, which is 12. We'll write down the 2, carry the 1. 3 times 3 is 9. 9 plus 1 is 10. Okay, we finished our first row. Now we're going to do our 5. Before we start with the 5, we want to put down a 0 underneath our 8, underneath our 1's column, so that the first number lines up under the 10's column. And then multiply 5 times 6, which is 30. We'll write down the 0, carry the 3 on top of the 2. 5 times 2 is 10. 10 plus 3 is 13. So write down the 3 and carry the 1 above the 4. 5 times 4 is 20. 20 plus 1 is 21. We'll write down the 1, carry the 2 in that 21 over on top of the 3. And then 5 times 3 is 15. 15 plus 2 is 17. We'll write out that whole number because there's nowhere else to carry. And now we'll add. So we have 8 plus 0, 7 plus 0, 2 and 3 is 5, 1 and 0 is 1, 7 and 1 is 8, and 1. So our final answer is 181,578. Hopefully you got that as well. Another one. Let's do more digits this time. 7,956 times 264. Start with our 1's column, of course, with our 4. 4 times 6 will give us 24. Write down the 4 and carry the 2. 4 times 5 is 20. 20 plus 2 is 22. So we'll write down 1, 2, carry the other one. 4 times 9 is 36. 36 plus 2 will give us 38. We'll write down the 8 and carry the 3. And then 4 times 7 is 28. Plus the 3 gives us 31. So there's our first row. Let's start with our second row then with our 6. And before we start with the 6, make sure that you put a 0 so that our first number lines up with that 10's column. And then 6 times 6, which is 36. Write down the 6, carry the 3. 6 times 5, which is 30. 30 plus 3 is 33. So write down 1, 3, carry the other one. 6 times 9 is 54. 54 plus 3 is 57. So write down the 7, carry the 5 above the 7 here. And then 6 times 7, which should give us 42, plus the 5 will be 47. All right, third row now are 2. And because now we're moving over to our starting number in the hundreds column, we want to put down 2 zeros to make sure that our first number lines up with that hundreds column. So we have 2 times 6, which is 12. Carry your 1. 2 times 5 is 10. 10 plus 1 is 11. So write down 1, 1, carry the other one. 2 times 9 is 18. 18 plus 1 is 19. You'll write down your 9 and carry your 1. And then 2 times 7 is 14. Plus 1 is 15. Now that we're done, let's add it all up. So 4 plus 2 zeros. 6 plus 2 is 8. 8 plus 2 is 10. 10 plus 3 is 13. Carry your 1. 7 plus 1 plus 2 plus 3 is 10. Write our 0 and carry our 1. 9 and 1 is 10. 10 and 3 and 7 is 20. So write down our 0, carry our 2. 4 plus 2 is 6. 6 plus 5 is 11. So write down 1, 1, and carry the other one. And then 1 and 1 is 2. So we get 2,100,384 as the answer for 7,956 times 264. Now, hopefully you're noticing there's a lot of detail involved in this. Keeping your math very neat and organized is of paramount importance for actually all the topics we're going over tonight. Getting graph paper can be very, very helpful for you for this. Also, if you have missed a problem or two, and I'm sure some of you have, you've probably noticed it doesn't take much to throw off a problem. Right? You could have an issue with your multiplication, you could have an issue with your adding right here. It's very, very small things usually that cause my students to miss problems. It's generally not issues with technique. So pay close attention to detail, double check everything, go back through your multiplication, make sure that each multiplicator is right, and practice your times tables. Let's see, one more. 856 times 232. Again, pause the video, go ahead, do this on your own, see what you get. We'll start with our 2 in our ones column. 2 times 6 is 12, write down our 2, carry our 1. 2 times 5 is 10, 10 plus 1 is 11, so write down the 1 in the ones place, carry the 1 in the tens place. And then 2 times 8 is 16, 16 plus 1 is 17. Okay, next row over, starting with the 3. We'll start with 3 times, before we start with the 3, make sure you put your 0. And then 3 times 6, which is 18, carry our 1. 3 times 5 is 15, 15 plus 1 is 16, write down the 6, carry the 1. And then 3 times 8, which is 24, 24 plus 1 is 25. And then last row, we do our 2 in the hundreds column. And because we're starting in the hundreds column, we want to put down 2 zeros to make sure our first number lines up in that hundreds column. So this is going to be just a repeat of our first 2 that we multiplied, a repeat of our first row. So 2 times 6 is 12, carry your 1. 2 times 5 is 10, plus 1 is 11, so write down 1, carry another 1. 8 times 2 is 16, 16 plus 1 is 17. Now that we're done, let's add them all up. We should get 2, 1 and 8 is 9, 7 plus 2 is 9, 9 plus 6 is 15. Carry your 1. 1 plus 1 is 2, 2 plus 5 is 7, 7 plus 1 is 8, 7 plus 2 is 9, and 1. So 198,592. Hopefully, much of this is review. If you have questions or if this is not review for you, come by office hours or send me an email and we can talk about this together. All right, moving on to division. Some more vocabulary to know. The divisor in a division problem is the number on the outside of the division box, the one who's doing the dividing. The number that's being divided, the number on the inside of the division box, is the dividend. And then when you divide those two, you get a quotient, which is the answer to your division problem. For the sake of whole numbers, for the sake of what we're doing now, your smaller number should always be on the outside of the division box. The smaller number should always be your divisor. This will not always be the case when we start looking at things like decimals and fractions and going back and forth between the two. But for now, the smaller number should always be on the outside of the division box. Your answers will all have remainders, so do be expecting that as you're working through your homework. And no, the remainder is not the same as the little decimal that you get at the end of your problem if you plug it into a calculator. If you're putting down a decimal for your answer, you will lose half a point. Make sure that you are putting down your remainder. 1, because I'm looking for a remainder. 2, because then I know that you didn't actually do the problem, you just plugged it into your calculator. We will look at decimals and dividing by decimals in the future, the very near future. So here's a good example problem right here. Going off of our vocabulary, your divisor is on the outside of the box, so in this case our divisor is 12. The dividend is on the inside of the box, so here our dividend is 492. And then when we divide that, we will get a quotient, which is the answer to that division problem. So let's look at a couple of examples. I found that quite usually Long division is the part that makes my students very nervous. A lot of it because there are a lot of steps that all need to be done properly. So let's start with something fairly simple. 391 divided by 7. And yes, I know, for those of you who realize this is a square root sign, not a division sign. You can't do a division sign in PowerPoint for whatever reason. Don't at me. So 391 divided by 7, we'll start by saying, well, will 7 go into 3? We want to start by finding the smallest number we can divide by 7. Can we divide 3 by 7? We can't. 3 is smaller than 7. If I have 7 kids and I only have 3 cookies, not everyone's going to get a cookie. And those of you who have kids know that if that's the case, there will be much wailing and unhappiness. So we cannot divide 3 by 7. Will 7 go into 39? Can we divide 39 by 7? We'll just move 1 over. And we can. 7 will go into 39 because 39 is greater than or equal to 7. So how many times? 7 times what will get us close to 39 without going over? Well, 7 times 5. 7 times 5 is 35. So we'll write the 5 over the 9 because we're dividing into 39. And then we'll multiply that 5 times our 7 times our divisor. 5 times 7 is 35. We write that right underneath the 39. And then we subtract and see what we have left. 39 minus 35 is 4. So far, so good. So now we want to know, now we want to bring down our 1. This guy right here, the next number over. And now we want to know, what is 41 divided by 7? How many times can you put 7 into that without going over? Well, we know 7 times 5 is 35. Could we go 1 up? What's 7 times 6? 7 times 6 is 42. That's too much. That's greater than 41. We can't use 6. So it's going to be 5 again. We'll write our 5 over our 1. Go 5 times 7 is 35. We'll write that 35 underneath the 41. And then subtract. And when we do 41 minus 35, we should get 6. This 6 is our remainder. We have nothing else over here to pull down, no other numbers to bring down like we did with the 1. So that 6, we're just going to write 55, remainder 6. Done and done. Now, this is not the same, like I said, as what you see when you plug this guy into a calculator. Because if you were to plug this problem into a calculator, your answer that you get is 55.857142.9. This is not a remainder, this is a decimal. This is the equivalent of our remainder over a divisor, 6 over 7. Don't worry about this, we will get to this in a little bit. All this is suffice to say, do not enter a decimal for your answer, enter this. Let's look at a few more examples. 11 into 583, or 583 divided by 11. So here we have a double-digit number as our divisor on the outside. Oh dear, what do? Can we break it apart, divide half of it by 1 and the other half by 1? So for this, we're just going to use 11 as a whole. And just like 7, or just like our previous number, we're going to ask, does 11 go into the very first number we have, our 5? Can we divide 5 by 11? We can't divide 5 by 11 because 5 is too small. Again, if you have 11 kids now and 5 cookies, it's going to end very poorly. So let's go 1 number over and say, well, how about 58? Will 11 go into 58? And 11 will go into 58 because 58 is greater than 11. So 11 times what will get us very close to 58 without going over. And again, this is where knowing your times table will be infinitely helpful. Well, 11 times 5. 11 times 5 is 55. That's very close to 58 without being greater than 58. So we'll write that 5 over the 8 and then do 5 times 11 to get 55. We're going to subtract that from the 58 and see what we have left over. 8 minus 5 is 3. We have 3 left over. Okay, next step. Bring down the next number right to the right. So we'll bring down that 3. Now we want to know how many times does 11 go into 33? Well, 3 times 1 is 3, so 3 times 11 would be 33. So 11 will go in 3 times. So write the 3 over our 3. 3 times 11 is 33. Subtract, get 0. So there is no remainder for this problem because what we have left is 0. We don't have anything left here to bring down, so we're done. Our final answer is 53. Now, how do you check a division problem, aside from plugging it into the calculator? Well, we would check this guy by setting up 53 times 11. 3 times 1 is 3, 3 times 5 is 5, or 0, 3 and 5 again. Multiply, add together, 583. We should be able to multiply our answer times our divisor. These two multiplied together should give us our dividend, the number on the inside of the division box. We'll look at how you check that if you have a problem with a remainder. Let's look at 2 more division problems, and then we'll take a look at some order of operations. So this is an example from your homework, so you might want to pay careful attention to this. We have 543 divided by 26, which looks terrifying. One of the things that you can do when you have a big number in your divisor like this is to start by writing out the times table for that divisor, so you have it at hand. So we could start with 26 times 1, which is 26, 26 times 2, which should give us 52, and then just because we can, let's do 26 times 3, which is 78. So here we have just kind of a general idea of the first few numbers in our 26 times table. This will give us something easier to work with. So let's start. 26, will it go into 5? No, it will not. Definitely much bigger than 5. Okay, let's move over 1 and ask, will it go into 54? And it will. 26 will go into 54 twice. 26 times 2 is 52. That's pretty darn close to 54. So we'll write the 2 above the 4. Very important to make sure your numbers are lined up properly. And then 2 times 26 gave us 52. Subtract. 54 minus 52 is 2. Okay? Bring down your 3. How many times does 26 go into 23? And hopefully you're looking at this saying, wait, but it doesn't. We can't put 26 into 23. Exactly. But we have to indicate that we at least looked at it and tried to figure it out. So how many times will 26 go into 23? Well, it won't. We can't put it in. And the numerical version of I can't do it is 0. 26 goes into 23 0 times because 26 is greater than 23. Now, we don't have any more numbers over here to bring down, so we're essentially done. We've finished our problem. What we do have, though, is our remainder. That 23 there is our remainder. So how do we check this problem if we're going to multiply and see if our answer is right? Well, we'll start with our quotient, our answer, times our divisor, the 26. 6 times 0 is 0. 6 times 2 is 12. Add a 0 for the second row. 2 times 0 is 0. 2 times 2 is 4. Add this together, we get 0, 2, and 5. So we multiply our quotient and our divisor, and now we're going to add that remainder. Plus 23 should give us 543. Should give us the answer that we started with in our dividend. So that is how you double check your answer when you have a remainder in your multiplication problem. Multiply your answer and the number on the outside of the box, and then add your remainder to that answer. Let's look at another example that's kind of similar to this. This is also a problem that you'll see on your homework. 271 divided by 3. Okay, let's start with 3. 3 won't go into 2 because 2 is too small. How about 3 into 27? Those of you who are very familiar with your times tables know that 9 times 3 is 27. So 3 will go into 27 9 times. So 9 times 3 is 27. We'll write that 27 right underneath our 27 and then subtract. we'll get 0, and bring down your 1. How many times will 3 go into 1? Will it go into 1? It won't go into 1. We can't divide 3 into 1, so we have to put a 0 here. And then that 1 that's left over will become a remainder. So 90 with a remainder of 1. Okay, let's go a little hypothetical. Let's say that instead of 3 into 271, we had 3 into 270, or 2,700 and, I don't know, 12. No, let's make it 13, something uneven. 3 into 2,713. So we did have another number at the end we could bring down. So this will start just the same as the last problem. 3 goes into 27 9 times. 9 times 3 is 27. Subtract and get 0. Bring down your 1. Oh no, 3 won't go into 1, so we have to put a 0. Now what? Well, now we're just going to start bringing down numbers until we find something that does work. So let's start with our 3. We'll bring the 3 down and say, does 3 go into 13? And 3 does go into 13. 3 times 4 will give us 12, which is as close as we'll get to 13 without being higher than 13. Subtract and get 1, and you should get a remainder of 1. So that's how we deal with those zeros when they crop up in problems, and you will see problems like this on your homework. Make sure that you write that 0 in when we indicated that we tried to put 3 into 1, but 3 doesn't go into 1. And then after you put that 0 in, you'll just bring down the next number and keep going until you find something that actually works. So let's look at the last topic for this lecture, the last topic for whole numbers, which is order of operations. Now we're going to put the whole thing together. Order of operations is our please excuse my dear Aunt Sally, which I find most of my students are usually very excited to see again. They all love their Aunt Sally. Mostly because this is like the one thing we remember from being drilled in our head from middle school math. Order of operations tells us if we have a great big long math problem with lots of different functions, which function do we do first? So PEMDAS, you probably remember, is parentheses, exponents. We don't have any exponents in our math class here, so I leave it in anyways because then we have PEMDAS and it doesn't roll off the tongue as nicely. Parentheses, exponents, multiply, divide, add, and subtract. Please excuse my dear Aunt Sally. So there are 3 steps, 3 rules to good order of operations that you need to remember. The first one is you'll do everything that's in parentheses first. That's why parentheses comes first. If you had exponents, then you would do exponents. We don't have exponents in this math class, so you don't have to worry about that. Second rule is to do all of your multiplication and division going left to right, whichever problem shows up first. I know that it's written multiply first and then divide. We're just looking to see what shows up first. Maybe going left to right, your first problem is division instead of multiplication. After you've done all of your multiplication and division, you'll do all of your addition and subtraction also going from left to right, whichever problem shows up first. So let's look at a few examples of this. Here we have 17 minus 6 divided by 2, in parentheses, plus 4 times 3. What do we do first? Well, we know because of our P that we're going to start with our parentheses first. So we'll look at this 17 minus 6 divided by 2. Okay, we have 17 minus 6, we have 6 divided by 2. Which one do we do first? Well, remember, rule number 2 states we do all multiplication and division first, going left to right. And in our little parentheses right here, the first thing that we find there is a division problem, 6 divided by 2. So we'll do that. Always copy down your problem as you're going in order of operations. So 17 minus, let's do our 6 divided by 2, which is 3, parentheses plus 4 times 3. Okay, we got our multiplication division out of the way. Now let's finish with our parentheses. We have 17 minus 3. 17 minus 3 is 4. And then we have plus 4 times 3 equals, we don't know yet. All right, we got step 1 out of the way. We took care of our parentheses. We don't have any more parentheses. Now, we have 14 plus 4. We have 4 times 3. What are we going to do first? We'll do our multiplication first. Remember, multiplication and division is our second rule. Multiply and divide before adding and subtracting. So 14 plus, and we'll do this, 4 times 3, which is 12. And now we'll finish adding. 14 plus 12 is 26. That's our final answer. Very important to make sure as you're going through order of operations that you're writing down the problem with each subsequent step written into it. As I've said many times, and will continue to say, don't try and do this in your head. Let's look at this one. No parentheses, but dear heavens, is it long. Okay, we have 6 times 4, 4 divided by 12, plus 72 divided by 8, minus 9. Where do we start? Well, we have no parentheses, so we don't have to worry about that. Don't have to worry about exponents. Multiply and divide, left to right, whatever comes first. So the first thing that we see going left to right is this 6 times 4. So we'll do that. 6 times 4 is 24. And then copy down the rest of the problem. Divided by 12 plus 72 divided by 8 minus 9. Okay, multiply and divide. Let's keep going until we've gotten rid of all of our multiplication and division problems. So going left to right, our first multiplication or division problem that we run into here is this 24 divided by 12. And 24 divided by 12 is 2. So 2 now plus 72 divided by 8 minus 9. Let's finish up our multiplying and dividing. We don't have any more multiplication, but we do have some division. We have 72 divided by 8, and 72 divided by 8 is 9. So we'll have 2 plus this guy here, which is 9, minus 9. So we finished our multiplication, we finished our division. Now let's do our addition or subtraction, and this is going left to right, whatever we find first. So first thing we find is 2 plus 9, which is 11, minus 9, and 11 minus 9 is 2. That is our final answer there. Another example, oh my word, here we have brackets. We have a parentheses with inside a parentheses, like that Inception movie. So these are brackets, these little square, they look like square parentheses. And you do brackets first. A bracket is like a parentheses outside of a parentheses. So we'll do everything within our bracket first, and specifically everything within the parentheses inside the bracket first. You want to go as interior to the problem as you can. So the first thing we'll do is this right here, our parentheses, which is 2 minus 0, and 2 minus 0 is 2. Keep them in this little parentheses, because he's written next to that 8, and being written next to the 8 in the parentheses means multiply. Okay, so now we've got to finish off our bracket here. So 8 times 2, which is 16, plus 6, 4, plus 3. Okay, finish our bracket. We have an addition problem in there. 16 plus 6 will give us 22. And we'll write that inside the bracket, because this bracket next to the 4 indicates that we're going to multiply, as if we had a parentheses there instead. So now that we've basically cleared out our bracket, we're done with that, we got no exponents. Multiplication, division, addition, subtraction, going left to right. The first thing that we'll find here is a multiplication problem, 22 times 4. And 22 times 4 is 88. 8 times 4 is 2, 22 times 4 is 88. So our last step then will be to add 88 plus 3 will give us 91. Let's look at one more example with a bracket. So here we have 5 plus 2 times 9 minus 2 times 4 minus 1. Close bracket. So start with our bracket, and not just our bracket, but start with the parentheses inside the bracket. So that will give us 5 plus 2, 9 minus 2, parentheses, 4 minus 1 is our first step, and 4 minus 1 is 3. Close parentheses, close bracket. Okay, next, now we have to finish up our bracket. We'll do our multiplication first, m and d fresh before adding and subtracting. So we have our little 2 times 3 right here. So 5 plus 2 times 9 minus 2 times 3 is 6. Now we have to finish up our bracket. We'll finish up our bracket by doing 9 minus 6. 9 minus 6 is 3. Keep that 3 in a bracket because that indicates we're going to multiply it to that 2 because that 2's written right next to it. So we finished up our bracket. Now we need to multiply first. 2 times 3, which is 6. And then we have 5 plus 6, which will give us 11. And that is our final answer for our problem. So hopefully this has been a very nice review, these last 3 lectures, of all of our basic functions, and hopefully you're feeling more comfortable with them. If you are not, or if you'd just like extra help, or if you'd like extra problems to practice, please email me or drop by office hours. I'd love to see you there, and good luck on the quiz.